5 things that do not make sense. Number 5. Dark energy. It is one of the most famous and most embarrassing problems in physics. In 1998, astronomers discovered that the universe is expanding at ever faster speeds. It's in effect still searching for a cause. Until then, everyone thought the universe's expansion was slowing down after the Big Bang. One suggestion is that some property of empty space is responsible. Cosmologists call it dark energy. Albert Einstein was the first person to realize that empty space is not nothing. Space has amazing properties, many of which are just beginning to be understood. The first property that Einstein discovered is that it is possible for more space to come into existence. Then one version of Einstein's gravity theory, the version that contains a cosmological constant, makes a second prediction. Empty space can possess its own energy. Because this energy is a property of space itself, it would not be diluted as space expands as more space comes into existence, so more of this energy of space would appear. As a result, this form of energy would cause the universe to expand faster and faster. Unfortunately, no one understands why the cosmological constant should ever be there, much less why it would have exactly the right value to cause the observed acceleration of the universe. Number 4. Antimatter Mystery. The Big Bang should have created equal amounts of matter and antimatter in the early universe, but today everything we see from the smallest life forms on Earth to the largest stellar objects is made almost entirely of matter. Comparatively, there is not much antimatter to be found. Something must have happened to tip the balance. One of the greatest challenges in physics is to figure out what happened to the antimatter, or why we see asymmetry between matter and antimatter. During the first fractions of a second of the Big Bang, the hot and dense universe was buzzing with particle-antiparticle pairs popping in and out of existence. If matter and antimatter were created and destroyed together, it seems the universe should contain nothing but leftover energy. Nevertheless, a tiny proportion of matter, about 1 particle per billion, managed to survive. This is what we see today. In the past few decades, particle physics experiments have shown that the laws of nature do not apply equally to matter and antimatter. Physicists are keen to discover the reasons why. Researchers have observed spontaneous transformations between particles and their antiparticles, occurring millions of times per second before they decay. Some unknown entity intervening in the process in the early universe could have caused these oscillating particles to decay as matter more often than they decayed as antimatter. Number 3. The WOW signal. It was 37 seconds long and came from outer space. On the 15th of August 1977, it caused astronomer Jerry Ehrman, then of Ohio State University in Columbus, to scrawl "WOW" on the printout from Big Ear, Ohio State's radio telescope in Delaware. Still, no one knows how the signal was created. Coming from the direction of Sagittarius, the pulse of radiation was confirmed to a narrow range of radio frequencies, around 1420 MHz. This frequency is in a part of the radio spectrum in which all transmissions were prohibited by international agreement. Natural sources of radiation, such as the thermal emissions from planets, usually cover a much broader sweep of frequencies. So, what caused it? The nearest star in that direction is 220 light years away. If that is where it came from, it would have to be a pretty powerful astronomical event, or an advanced alien civilization using astonishingly large and powerful transmitter. Number 2. The placebo effect. If you induce pain in someone for several times a day for several days, and you control the pain with morphine until the final day of the experiment, when you replace the morphine with a saline solution, the saline takes the pain away. This is the placebo effect. Somehow, sometimes, a whole lot of nothing can be very powerful, except it's not quite nothing. When Fabrizio Benedetti of the University of Turin in Italy carried out the above experiment, he added a final twist by adding naloxone, a drug that blocks the effects of morphine to the saline. The shocking result? The pain-relieving power of the saline solution disappeared. So what is going on? Doctors have known about the placebo effect for decades, and the naloxone result seems to show that the placebo effect is somehow biochemical. But apart from that, we simply don't know. Benedetti has since shown that the saline placebo can also reduce tremors and muscle stiffness in people with Parkinson's disease. He and his team measured the activity of neurons in the patient's brains as they administered the saline. They found that the individual neurons in the subthalamic began to fire less often when the saline was given, and with fewer bursts of firing, the neuron activity decreased at the same time as the symptoms improved. The saline was definitely doing something. Number 1. The Bloop. In 1997, researchers listening for underwater volcanic activity in the southern Pacific recorded a strange, powerful and extremely loud sound. Using hydrophones, or underwater microphones, that were placed more than 3,219 kilometers apart across the Pacific, they recorded numerous instances of the noise, which was unlike anything they'd heard before. Not only was it loud, but the sound also had a unique characteristic that came to be known as the bloop. Scientists from NOAA's Pacific Marine Environmental Laboratory were eager to discover the sound's origin, but with about 95% of the ocean unexplored, theories abounded. Was the bloop from some secret underwater military exercises, ship engines, fishing boat winches, giant squids, whales or some sea creatures unknown to science? The most popular speculation about slowdown is that it was caused by the breakup of the Antarctic ice, which means it might give an indication of climate change.